Okay, so piecewise, some functions are represented by two or more pieces. Like I was just saying, I don't think you see that on the video. That it could be a quadratic and then followed by a line. We're just going to do various functions. They're called piecewise functions. Each piece is defined for a specific domain. So each piece will have its own domain. So for instance, this could be if you're jumping from a plane, this part here might be the first, I don't know, 30 seconds. So your domain will go from 0 to 30. And then this part might be another 30 seconds. So from 30 to 60. So each piece has its own domain. It has its own x values associated with that piece. That's what that means. To graph a piecewise function, just graph each piece individually over the interval, and that's it. So we're going to show two examples here. And then so graph each one and ask if they are continuous. Okay, the continuous part is the same as we did in 1.3 when we asked if there's any discontinuation or continuous. Okay, remember that chart we did? So the same thing, and we're looking to see if the graph is continuous or not. Okay, so this is how you read. It looks really weird, right? But I'll show you how to read it. So read it as in pieces, okay? If you want to separate them, you can. So the first function is this, but it's restricted such that x is less than 2, okay? And then we have this function here if x is greater than or equal to. So just show you what it means. So f at x, you don't need to write this if you don't want to. So the first part is x squared minus 1, okay? And then the second part is a linear function. So f at x equals x plus 1. Okay, so the two functions are quadratic and linear. Okay, so the first part and the second part. Okay, but we're not going to graph this whole quadratic. We're not going to use all of it. What it's saying is we're going to only use x values less than 2. So for this graph, we're only using values less than 2. The easiest thing is just plug in x values. So if I'm using the first one, so I want values less than 2. I'm going to use 2, but then I'm just going to put an open circle. So I'm going to go 2, 1, 0, negative 1, negative 2. And we're just going to plug values in. Plug values in and get for the y. We'll get the y coordinates. Okay, so mental math here. If I plug 2 into the function, so I get 2 squared is 4, minus 1 is 3. So my answer is 2 and 3. Okay, just plug in values in. If I get 1, I plug 1 in, 1 squared is 1, minus 1 is 0. You can plug values in, or you can use the shortcut. I should have done that. Should have did the shortcut and then just erase. I'll do that after. 0, plug in. 0 squared is 0, minus 1 is minus 1. Plug in negative 1. Negative 1 squared is 1, minus 1 is 0. And lastly, negative 2 squared is positive 4, minus 1 is 3. should have just did the shortcut. Let's do the shortcut here. And we'll just show you how they relate afterwards. Okay, so this is, we said is a quadratic. Okay, so x squared usually starts at 0, 0. But what happens with the minus 1? We go where? Down 1. So down 1, and then use the pattern. So 1 to the right, 1 up. 1 to the right, 3 up. 1 to the right, 7 up. But don't worry, I'll erase. Don't copy this out. Don't copy this out yet. Then do the same on the other side. 1 left, 1 up. 1 left, 3 up. And then over here. Okay, but, so I graphed it, but it says it has to be the x values that are less than 2. So I can't have these values because these are greater than 2. So I erase this piece. Okay? If it says less than 2, but not equal to, what should I do with this dot here, this point? Who said it? Valentina? It should be a hole, right? So it should be an open circle or a hole. And you'll see that these correspond, right? So 2 and 3, 1 and 0, 0, negative 1, negative 1, 0, negative 2 and 3. Okay, now the next part is what type of function we have here? We have a linear function, so x plus 1. So all our values are greater than or equal to 2. Again, you can make a table of values. Start with 2 and go upwards. So 2, 3, I'm just going to do 3 points. Since it's linear, it'll just be the same pattern. Actually, I'll just do 3. Okay, if I plug 2 into the equation, so I have 2 plus 1 gives me 3, good. If I plug 3 into the equation, 3 plus 1 is 4. And if I plug 4 in, I get 5. Yes?
You need to start it on point 2 and 3.
I'm gonna get there. Okay. Everyone's thinking about it, I know right now. The point 2 and 3, what happens? So this one, it wasn't included the 2 and 3, but this one includes 2 and 3. So what should we do at this point? 50-50 shot. Leave it as is, color it in. Which one? We do? Who said it?
Because it does touch the point.
Yeah.
It's not from
So now this includes that point, so now we color it in. Because of this, because this is x equal to 2. So when we had x equal to 2, it was 2 and 3. So that point now, it's included. And now we just plot the rest. So 3 and 4, and 4 and 5. And since it's a line, it's linear, it just is continuous. So again, to read this, split it into 2 parts. So first it's the function, the quadratic, but we can only use x values that are less than 2 here. So we have to use 2, 1, 0, negative 1, negative 2, and so on. Okay, so values only less than 2. Then we have a second part of the function, which is x plus 1, which is linear. But for this one, we can only use values greater than or equal to 2. So 2, 3, 4, 5, and onwards. Okay, second part of the question is, are they continuous? Is this a continuous graph? Austin?
Yeah.
Yes. Okay, why? Why is it continuous?
Because the domain and range are both x, e, r.
Okay, it's continuous. Okay, but more specific, you're right. Something else though? Because this could stop here. We could stop this here, but it'll still be continuous. Jasmine, do you have any more?
Is it because there's no break?
There's no breaks. Okay, there's no breaks in the graph. So yes, this is continuous. Yes. So continuous meaning no breaks. It doesn't necessarily have to mean that it goes. It doesn't necessarily mean it continues both way. One could stop, which is fine, but there's no breaks in the graph. Last one. So you guys can get a little try for this one. So the first one is an absolute function, where your values are less than 0. And then your second one is a square root function, the value is greater than or equal to 0. But make sure that's a +2 on the outside, so that moves 2 units up. So go ahead and give it a little try. So x value is less than 0. So -1, -2, -3, -4. Should know what that looks like in an absolute function. And then we have the square root function. For this purposes, guys, we'll just do one arm of the function for square root. Okay, we're not gonna do 2, we'll just do one arm. Okay, so let's go through the first one. I'll make a table of values, but you probably shouldn't need one for the absolute function. But we're using values that are less than 0. But you could actually use 0, but just when we use it, we just put an open circle there. So let's go less than 0. So we'll have, I'll count backwards. So 0, -1, -2. Okay, I'm just gonna do 3 points because an absolute function is just, it's a v, so it's 2 straight lines. Okay, so we know at the parent function, it should be like this. Okay, but we're not using values larger than 0, so it should look something like that. So we plug it in, plug 0 into the absolute function, you remove the brackets, it's still 0. So 0, 0, but we're not, it does not include 0, so we're gonna put an open circle or a hole there. If I plug -1 into the absolute, what's my answer?
1.
+1. And if I plug in -2, it is? +2, good. So I have -1, +1, -2, +2, -3, +3, and so on. So we get something that looks like that. Okay, which I think everyone had. Everyone got that part. Okay, now the square root function. So we want values that are greater than or equal to 0. When you're doing a square root function, if you want, what would help is pick values, since it's just x square root of x, pick numbers that can be square rooted. It just makes it easier. Okay, so we're gonna start at 0, because if we square root 0, it's 0. What's another number I could use that could square root nicely?
4.
4, I'll get to 4. What's before 4? 1, cool, so 0, 1, 4, and give me one more? 9. Okay, so I'm gonna use those values. If you use 0, 1, 2, 3, that is fine. That is perfectly fine. Okay, it's just gonna give me whole numbers at the end. Okay, so if I plug 0 in here, into the square root function, square root of 0 is? 0 plus 2 is 2. Substitute 1 into the square root function, square root of 1 is 1, plus 2 is 3. Substitute 4, square root of 4 is 2, plus 2 is 4. And lastly, substitute 9, square root of 9 is 3, plus 2 is 5. So I have 0, 2, 1, and 3, 4 and 4, and 9 and 5. So something should look more curved. So it's like that. Again, if you didn't use 0, 1, 4, 9, that's fine. You can use 0, 1, 2, 3. So again, we put a closed circle here because it's greater than and equal to 0. So we include this point. Does that make sense? Okay. Last part of the question, is this continuous?
No.
It's not. Okay, there's a break here. Okay, so there's a break. So not continuous. Sorry. I'm gonna write discontinuous. And then you have to say where it's discontinuous. So discontinuous at what x value? At x equals
0.
0. Okay, so this is where x is 0. So it's discontinuous at x equals 0. Is the homework at the bottom of the page? Some of you guys, some didn't. You have it, you don't have it. You don't have it. Okay, I'll just put it here. Keep forgetting I gotta list it here. Okay, so the homework, but you have another 35 minutes. Page 51, 1 to 4, 6, 9. It's not very difficult, just a bunch of graphs for this. And then tomorrow, what we're working on with, where it would be with cohort B, will be the review. So all questions are fair game. Do you have to do every single question, every single letter? No. But the more you do, the better you'll be off. So if it's a question that says 1 A, B, C, D, E, F, and it's asking you to do domain and range, maybe do A, C, E. It's up to you. Okay, so homework, these ones I want you to focus on and then do the review. This review is for tomorrow.